Luis, can you watch this?
I gotta check this.
Me too.
Hey. Ready? Go.
Hey everyone, we're Stark Industries. We are a full-service architecture and engineering firm based in Oklahoma City, founded in 1987. We specialize in sports facilities and event centers with a focus on sustainable engineering. Our current project, which we are extremely excited about, is the Texas Tech Sports Performance Facility, which I will now hand over to CJ for more details.
Hi everyone. Okay, so I'm going to give you a little refresher on the design parameters that we have for this project. So as you can see in this picture, the new Texas Tech Sports Performance Center is going to be replacing the training facility as well as the 2 practice fields. Now for this lot, it is approximately 5.7 acres, and the roads that we have surrounding the lot, we are planning to keep operable during the time of construction. Okay, so for our budget, we have about budgeted $48 million, which includes the installation of an indoor track facility as well as a football field and other amenity spaces such as a weight room and offices, nutrition bar, stuff like that. The total square footage of the building is 185,000 square feet, and it will be able to accommodate 2,000 seating for the track, 750 permanent seating will be right here, and then the remaining seat will be able to open up with this partition that meets the football field to be able to put in temporary seating when needed. And then the other design parameters that we have is for the football field, which will have a minimum height clearance of 65 feet. So now I'm going to go into our organizational chart. This is going to introduce our team and then lay out the details of the responsibilities of our team. So we have Jake Rosworm, he is our project manager and team leader. We have Jeremy Ng, he is doing the transportation. Yari is doing the water resources. Shaz Ideal is doing the geotechnical design. Skylar Calhoun is doing the structural design. And then Josh is going to be doing the construction management. Now I'll go ahead and hand it off to Jake to present his individual design task.
All right, good afternoon everyone. I'm Jake Rosar. I'm the team lead. I'm also the structural gravity lead for our system. So we are going to be using ASC 710, the Lubbock Code of Ordinances, and the IBC 2009 code for governing our design. We decided to go with a roof panel system from Volcraft that utilizes a 3N narrow rib system. And this is an LRFD driven design. So a preliminary roof design that we have looked at is using K-joists to span between the main system trusses along both sides of the facility. There are 24 main trusses that will carry the predominant load to the columns. We have considered with uplift that might be a problem with the joists as it is a lighter system, so we may move to a purlin support system. The bridging will probably be required for torsional resistance in the system to help with the wind load. According to my chart here, I'm, as you can see, pretty much on schedule. Just got to complete a few more drawings and finish running some analysis on my trusses that I have currently. I will be moving into connection design for future work as well as assisting with Skylar on the columns. I'm going to hand it over to Skylar to talk about the lateral system.
Hi everyone. So I'm doing the lateral system, and so one of my first the tasks were to determine what type of building I have and the criteria that it has for both wind and seismic. I found that my structure was a risk category 3 building, where in Lubbock it had a basic wind speed of 120 miles per hour, and also a exposure category B due to the fact that it's in Lubbock and it's a suburban area and it has buildings partially blocking the wind. And I consider the building to be a partially enclosed, but I'm also doing an analysis for an enclosed structure. Next slide. And I also determined for the building the seismic. I found that the site actually had a stiff soil area, and then it was a site class D according to the USGS website. And I found that the response accelerations were roughly 0.083 G, and the 1 second response acceleration was 0.052 G. And according to the McCarley scale, the building would have a potential of no damage if an earthquake was to occur. And according to my schedule, I am on track. I fell a little bit behind on the wind loads due to the complexity of the building, but I plan to be back on track, and my next steps will be designing or creating drawings for the building.
Okay, so my name is CJ Allison, and I'm going to be talking about my 50% submittal for this project. Overall, my IDT is the lighting and electrical design for this building, and for the 50% submittal, my goal was to complete all of the lighting aspects. So what it comes down to is 3 major portions. The lighting analysis is basically determining the relevant information from each specific room in the building, as in the dimensions, length, width, and height of the building, and the use of the space, so offices, weight room, and that will actually be able to let me refer to the IESNA lighting handbook, which provides the required illuminance levels for each specific space in the building. After that, I'll be able to calculate the lighting load, which helps me determine the required amount of lumens for each space. And once that lumen determination is complete, I'm able to select luminaires, which comes down to the ones that I actually chose for the building, which has a range of them from troffers, step lighting, pendants, downlighting, and decorative lighting. And these next slides are actually some applications of examples of the lights that I chose. This high bay lighting is going to be for the gym or the football field and the track. It is LED. It is also dimmable, so it accounts for the sunlight that will be coming into the buildings with the windows. The next is the troffers. This will be primarily seen in the offices of the building, but it's also going to be featured in the weight room as well as the additional lighting that we're going to be able to see in there. The next is wall sconces. Now this specific one that I chose, all of the lighting that I chose was LED, but this one specifically is interior and exterior. So this will be serving as decorative lighting for the interior, but more specifically as decorative for the outside as well, for the facade of the building. And then the step lighting, now this is going to go, there are further steps out this way. The step lighting is going to go here and past these trees. There's a side of steps you can't see, but there will be step lighting there as well, so that during the evening times you will be able to safely go down the 6 steps. But also there will be the same amount of lighting right here where the ledge is. And then also the exterior lighting will feature wall washes to light up the building. Now I'm going to go over my design schedule. So my goal was to complete the lighting aspects of this. Based on the green, you can see that all the way up to the 50% submittal I have completed, which effectively completes all of the lighting portions of the building. Next, I'm going to attack the electrical portion, which includes determining the electrical loads for the building, which will have considerations of the hydrotherapy room, which will take a lot of the electrical load, as well as the scoreboards and basic lighting load. And then obviously the schematics will be in progress the entire time. So now I'm going to go ahead and hand it over to Yari, and she is going to go over the water resources design.
Hey guys, I'm Yari, and I am the lead for the water resource design. So in order to find peak flow, we first had to perform a precipitation analysis to the city of Lubbock, and found that Lubbock is considered to be a tropical and subtropical climate. So as you can see on the right, I have the average precipitation and temperature for each month for about 30 years of data. So from this, we analyzed the existing drainage for the campus now and determined runoff quantification based on elevation and topography to find the natural flow of in case of a rainwater event. Okay, so these are 4 different drainage areas. First, we have the parking lot. Second is a combination of the turf and grass practice fields. Third are the offices, and fourth is the facility. So what we did was we performed the rational method in each section based on area, rainfall intensity, and surface coefficient. And from this information, we plugged it into FlowMaster and found our pipe size and material, and decided to go with the rain garden idea for stormwater management. And this will also get us good points for lead. Okay, so this is a current schedule for the hydraulic design. As you can see, we are on time. We are actually a little bit ahead of schedule with the rain gardens. So the next step I will be taking is to design the rain garden. Now I'll hand it over to Jeremy to talk about the transportation and site design.
Hey everyone, I'm Jeremy. I'm the transportation lead for this project. Just real quick, these are a few graphs that show roadways present serviceability index, or PSI. These were developed by AASHTO to kind of just understand and learn more about how a typical roadway will fail. As you can tell from the first graph that obviously traffic is the main cause of pavement failure. And here is a typical rigid pavement design that I decided to go with. Depending on the subbase or subgrade of the project area and site, a base may or may not be used. And although the subgrade for Texas Tech is not particularly erodible, I decided to put in a 4-inch base of crushed aggregate, and on top of that will be an 8-inch concrete slab. And there will also be, we can go back one more. There'll be dowel bars and dowel baskets to help with load transfer. And here's an updated Gantt chart of mine. I'm a little behind schedule, but within the next week I'll be putting finishing touches on the roadway design and the parking lot design, and then the remainder will include creating drawings and exhibits for the project. I will now hand it over to Josh, who will talk about construction management.
Thank you. Good afternoon, everyone. My name is Josh. I'm the construction manager for Stark Energy Industry. This right here is just a breakdown of the project phases. After design, I broke down the construction into 3 different phases. We'll have the demolition and mobilization phase, which mainly consists of demolishing the existing structure, removing all the debris, and then mobilizing the equipment to remove that debris and start the construction. The next phase would be the structure and foundation construction. We'll start with the foundation first, and then move over to the parking lot, and from there we will start the steel and build the frame, and then do the interior finishes and exterior finishes of the steel. And then the final phase is the closeout, which is mainly just the interior and exterior finishes, and then inspection afterwards. Next slide. This right here is just an example of my RS Means cost estimation spreadsheet. All of the divisions that are up there are just the main divisions from RS Means, and then there's subdivisions below that that I'll put everything into, as far as masonry and concrete and everything that goes along with making a full spreadsheet for the cost estimation for the project. The next one. As far as what I'd love to do, I'm still pulling information from the architectural plans as far as the amounts of everything that will go into constructing the full cost estimate for the project. I still have to come up with milestones for each phase of construction, and make a master schedule for the construction project. And then as soon as my teammates finish their IDTs, then I'll start the cost estimations for each one of their IDTs. And then I can construct that and combine it with my full master estimation. And then I'm going to pass it over to Shaw, and he's going to finish us up with his geotech design.
Hi, I'm Shah Zariel, and I'm the geotechnical design leader for this project. So we were provided with soil subsurface exploration results, which consists of 14 boring log sheets. And as you can see, the locations of the borings are shown on this picture. And only 4 of the boring are located on where the actual building is going to be built on. And then the depth of boring was 35 feet. And it is found that within the top 35 feet of the soil, the groundwater and the bedrock were not encountered. And also based on the boring sheets, it is found that the soil is made out of layers of sandy clay and clayey sand. And then these 2 soils are classified as stiff clays based on the SPT N values. So based on International Residential Building Code, the presumed allowable soil bearing pressure for this type of soils ranges between 1,500 to 2,000 PSF. So based on the data that we have right now, and that is without the load from the structures, it is I recommend that we use a mat foundation for this project because it is cost effective and it reduces the amount of final and differential settlement. I'm basically where I've scheduled myself to be at 50% submittal, and moving on from now, I'm gonna focus on the actual foundation design and the drawings, and then the final completion of the 100% report. So as a conclusion, each of our team members are exactly right on track with their individual design tasks, and as a whole, it is safe to say that our group is right on track as well. So that is it. Any questions?
I have one for the geotech.
Yeah.
So for the boring walls, are you using all 14 or are you using a select few, or how are you?
Just like the select views, which is.
Are you using just those 4 that the building is, or are you going to use?
No, I'm going to use these 4 and including some of them. So number 2, 5, 8, 10, and like this part.
Okay.
Yeah.
I have one more question for you too. So you're commenting mat foundation.
Yeah.
Do you know how much settlement you expect to get?
Not yet. I haven't done that part.
Why are you using the IBC values if you have boring ones? I think the IBC is like if you don't have boring ones, there's kind of a minimum that you can go by.
It just because I went to Texas Code, I just wanted to
You should
put the
probably,
minimum value there.
yeah, but you should use correlations to get a higher value. This 2000s, it's pretty low.
The other one that I found was 3,000, and that is based on New Jersey code. I'm not sure if I can use that.
Yeah, I would look for correlations. And then you said the mats are inexpensive.
I mean, it's
Mats are really expensive.
as compared to
Like a shallow footing, or maybe even because you're gonna have like your whole football field or your indoor field. You're not gonna have any columns going over. You're gonna have this big mat supporting nothing. So I would just look at it again.
Your columns are 200 feet apart, so you're gonna have 180 feet of mat doing nothing.
yeah, I mean that's just a recommendation, so I can change that later on.
While we're on the geotech, and I just have to ask. So what's the difference between a sandy clay and a clayey sand? Is that like partly sunny and partly cloudy? No, there's sandy clay and there's clayey sand. There's got to be a difference between them. What's it? I mean,
It's
a lot of time.
It's a percent of the sand, or it's a percentage of. But I'm not really sure, but I'm sure that clay sand is like lower than
Yeah.
This one ranges from 1500 PSF, and this one has the higher soil pressure.
Well, that's okay, soil pressure, but define it. Does sandy clay have more clay and less sand, and clay sand has more sand and less clay?
I believe it has to do with the percentage of fines.
It's a percent of fines.
You should know that. Anything you ever put on your slides, you should know the answer to. Or don't put it on your slide. Because you guarantee you that Dr. Miller's going to ask you that.
I have a water resources question. You mentioned that Lubbock was a tropical slash subtropical climate. Why is that?
Okay, so that's probably the opposite from what you're thinking, but tropical and subtropical climate means a true desert and low elevations. So good for growing like succulents, not like jungle tropical, if that makes sense.
So your intro was good.
It was the same question.
What?
So what question? I was going to ask the
Yeah,
same
it
question.
sounds odd, like opposite from what you would think.
Yeah, 'cause
but
I thought it was an arid, semi-arid climate. So that's why.
Now, is that because you get some really high rainfalls
In
in
very
a
short
small,
period.
short period of time? That's what defines it?
Yes.
As opposed to, which makes sense.
Yeah.
Because that's what you have to design for. Doesn't matter if there's no rain for the next 9 months. So your intro was good. I like. Oh, go ahead. If it's a water question, you can't answer it. There's already been 2.
You may help us.
Okay, wow, she's doing fine. I'm worried about you.
Which method did you use to find your time of concentration?
I can't hear you.
Which method did you use to find time of concentration?
I used the Gami-Rinsley method. It was based on the size of the lot and a bunch of other small factors, but that's the method I used. So I didn't use the minimum required for the city of Lubbock, which was 10. I did a lot of different methods and tried to get as close to
Your intro was good. I like that you mixed it up with 2 people. That was a nice touch. Your schedule was hard to read. I couldn't read it.
The Gantt charts.
The Gantt chart. For everybody, because you guys obviously use the same one. Yours is can't.
What makes it less difficult to read?
Probably the black background and the small text. I mean, is it like, did Dr. Knott say you ought to use black backgrounds and white text in professional development?
He said use multiple colors.
He said make it a rainbow. Make it a rainbow. But yeah, if you go to one of the Gantt charts, I can't read it. And you got to remember, we're going to be in a room that can seat 80 people. And your final presentations would be somebody that's going to be farther away than the back of that wall. So just think about that. Skylar.
What's up?
Very detailed seismic analysis. How's the wind analysis going?
Oh, well, I have most of my